Okay, let's dive into this. Welcome to today's Explainer, where we're going to be tackling one of the absolute ultimate cosmic mysteries, and that is mapping dark matter. More specifically, we're going to look at how scientists actually managed to unlock the secrets of the galactic halo. I mean, if you've ever sat back and wondered how on earth astrophysicists can map out a massive structure that fundamentally refuses to interact with light, well, you are definitely in the right place today. Right out of the gate, we hit a massive scientific roadblock. Think about it. How do we observe the invisible? Dark matter is without a doubt the universe's most elusive suspect. It's essentially forcing astronomers to become these cosmic detectives, right? They literally have to track down a massive amount of material that leaves absolutely no direct visual trace in the night sky. And the challenge here, it isn't just that dark matter is invisible. It's that galactic halos themselves are incredibly vast and just extraordinarily diffuse. They extend way out, far beyond the bright visible disk of a galaxy that we're used to seeing. This massive structure completely evades our most powerful telescopes. If you point a massive lens directly at it, you get absolutely nothing.
Now, what's really interesting about this slide is how it shows the paradigm shift we need. Since taking the direct route is physically impossible, astrophysics demands a brilliant workaround. So astronomers rely entirely on indirect methods. Basically, instead of hunting for the dark matter itself, they meticulously analyze the surrounding environment. They're looking for the gravitational footprints, the little clues that the invisible mass leaves on the visible matter that's trapped inside it.
So what exactly are these cosmic detectives looking for? Well, we've got three crucial clues in our mystery here. We're looking at the kinematics, or motion, of halo stars, the behavior of background light passing through halo gas, and the physical distribution of ancient stellar clusters and streams. Let's go ahead and break down exactly how each of these works. First up, we look at the motion of visible halo stars. Because scientists obviously can't see the dark matter itself, they study the kinematics of these really ancient stars. By carefully tracking their precise velocities in their orbital paths, astronomers can actually calculate the sheer amount of unseen mass that's required to keep them tethered to the galaxy. Because without that hidden mass, those stars would just go flying off into deep space. Let's move to our second piece of evidence and see how this builds the case. This is where we observe background light as it passes through the halo gas. See, when light from distant quasars or faraway galaxies travels through our halo, the unseen mass can actually gravitationally lens, or basically bend, that light. At the same time, the diffuse halo gas imprints these specific absorption lines. So by studying exactly how that ancient light is warped or filtered, it gives us a direct physical profile of that invisible environment. Finally, we have our third clue. Astronomers analyze the distribution of globular clusters and stellar streams scattered across the halo. And you know, these things aren't just randomly placed out there. Stellar streams are often the remnants of dwarf galaxies that have been literally torn apart by the immense invisible tidal forces of the dark matter halo. By mapping out these massive cosmic debris trails, we can basically trace the exact shape of the gravity well that destroyed them in the first place. And this brilliantly illustrates how it all comes together. These three distinct environmental clues, the stellar kinematics, the warped background light, and the tidal debris, they all funnel into one massive scientific revelation. By taking these indirect observations, astrophysicists can plug this data into complex gravitational models to actually weigh the entire galaxy. So the crucial point is what happens next. Once they calculate that total mass, it basically acts as the master key. Knowing the mass is what allows scientists to move to the final step, which is rendering a three-dimensional map of the dark matter structure itself. They're literally constructing a topological map of a completely invisible framework purely by measuring the invisible gravitational hand that's pulling all the strings. It's just wild. Which leaves us with a rather profound question to think about as we wrap up. If we can literally map the invisible scaffolding of the universe, Just by studying how the visible environment reacts to it, what else is hiding in the incredibly faint halos of our galaxy? What's out there, just waiting for us to find the right clue? It's a truly fascinating testament to human ingenuity. Thanks so much for joining me for this explainer, and hey, keep your eyes on the stars.